So our new topic is numerical differentiation. So for the given data, you are given values x naught, y naught, x1, y1, and so on. So you have to find y is equal to f of x and then the derivative of the that function with respect to x. So remember what we do normally, that we are given a formula y is equal to x squared. So if I differentiate this one, I will get 2x. We will use power rule, but in our case, we are only given the data. So first we will find the polynomial and then we will differentiate it. So if we move down here, if I have 4 data points, like 5 data points, y0, y1, y3, and up to y4. So these are 5 data points. So the degree of the polynomial would be 1 less, it should be p4. So first we will find the polynomial and then we will differentiate. So one thing is important here. If the data is equally spaced, this one, find polynomial by using forward interpolation or backward interpolation. So if I'm asking about the initial points, then you will use Newton forward interpolation. And if we are asking about the bottom points, then you will use the Newton backward interpolation, but only in case of equally spaced data. So if our data is not equally spaced, then you can use other methods as well. So one of them is the divided difference method. So it depends on the question that what we are doing. So if we go down further here, so this is the problem. Find the first and second derivative of y or f of x at x is equal to 1.5. So this data is given to us 1, 2, 3, 4, 5, and 6. So 6 points are given from x0 to x5. So the degree of the polynomial would be 5. So check if the data is equally spaced. So it is 1.5 to 2 to 2.5. So they are equally spaced and the age value of h is 0.5. Yes, it is. This is written here in the notes. So it is 0.5. Now the 1.5 is at the start. So we must use the forward formula. We shall use either Newton forward or backward. But in this case, we are going to use Newton forward. Second check is derivative is required at x equal to 1.5 and 1.5 is at the beginning of the x values. So we shall use Newton forward interpolation. Moving forward, here is the table that we usually make in class. So this is, if we subtract 3.35 from 7, from bottom to top, 3.625. Then again, 13.625 minus 7 would be 6.625. And so on. 24 minus 13 point, this will give you 10.375. So if I'm going to subtract all these, so this upper diagonal is going to give us y naught, delta y naught square, delta cube, delta power 4, and delta 5. So Gregory Newton forward interpolation formula for 6 point is, it should give us a polynomial of degree 5. So this is the formula that we have been using in our first lectures. So we will use the same formula, putting in values from the above table. So you will get this formula. So again, some differences are zeros. So if you look at these two values, this is 0, this is 0. So the fourth degree and the fifth degree coefficients are 0. So the polynomial will be of only 3 degree. So here are 3 factors, 1, 2, and 3. So it is easy to differentiate. So we will use the product rule here. It is a linear factor. So the derivative of this factor would be 1. Here we can use product rule. And for this, we have to use product rule twice. First on the first two, then again on the third one. So if we look down here, 0 point, this is the values after differentiating. So it is a polynomial of degree 2. So putting values in here. So if we take the second derivative, again, here you will use a simple linear term is here. So answer is 2 here. Here we can use product rule, again product rule, and 3 times you will use product rule. So after differentiating, you will get this value. So this is 12, 2x minus 3.5. And in the end, you will get double derivative equal to 6x. So the original polynomial, if we look at the polynomial here, it was a polynomial of degree 3. After differentiating, it become a quadratic polynomial. And after double differentiation, you will get a polynomial of degree 1. Now the first derivative at x equal to 1.5, put x is equal to 1.5 in it. You will get the answer. Here it is 4.75. Second derivative, again we will put values 1.5 here, so answer would be 9. Now here is the second question. Find the first and the second derivative of the function at x equal to 1.9. So this point is at the end. So again, is it equally spaced? 1 to 1.2 to 1.4. So it is equally spaced. So 0.2 is the difference. The value of h is 0.2. Second check, as data is equally spaced. So either we can use forward or backward, but it is at the end. So we'll use Newton backward formula. So we shall use Newton backward interpolation. Again, in the same way, you will be subtracting 0 from 0.12. So from bottom to top, 0.12 minus 0, this will give you 0.128. Again, from bottom to top, 0.544 minus 0.128, you will give you 0.416. So following the same pattern as in the forward difference, now the backward differences are at in the bottom diagonal. So this is the first yn, again this one, and these in the lower diagonal, these are the values for the backward interpolation. Again, it is a 6-point data, so 5-degree polynomial, we should get 5-degree polynomial. So again, if you look at these two values, these are zeros. So fifth and fourth order are zeros, so it should be a polynomial of degree 3. Again, the old formula that we have been using in backward interpolation. So putting in the values from the table, you will get this expression. Again, last two terms are zero because the backward differences were zero there. Now this is a polynomial of degree 3. First derivative should be a polynomial of degree 2. So if we differentiate here, x minus 2 is 1. Here we can use product rule. Derivative of x minus 2 is 1. The derivative of this, because it is a linear factor, so it should be 1. So the differentiation is easy. You are just using power rule and product formulas. So here we are going to use it twice. So after differentiating, this should be a polynomial of degree 2. How can we say that? Because these two, x into x will become x square. So the second derivative should be a polynomial of degree 1. So again, we are using product rule here on this part, and it is a simple one. 2 is the derivative. So finally, you will get double derivative 6x. First derivative at x equal to 1.9 is this. So I would suggest that I will not give this 1.9. It should be one of the data points. So make a correction here. Instead of putting 1.9 here, if we look backward here in the data, I will give you only the data point. So it should be 2 here. Instead of 1.9, we should write 2 here. So we evaluate at the data points, not in between these. So it should be 2. Also, if you find any formula on the internet or on the AI, you can use that formula. So I don't mind if you want to use another formula for the differentiation. So going down here again, putting values, there it should be 2. You will calculate the value. So double derivative can be calculated. The next question is find single derivative at 3 and the double derivative at 3. Here is the data. So difference between -1 and 1 is 2, but the difference between 1 and 2 is 1. So this data is not equally spaced. So now we are going to use, so look at the solution. First check is data is equally spaced or not. So first difference is 2, other difference is 1 and 1. Here no data is, now the data is not equally spaced. So we are going to use divided difference method. So if you want to use Lagrange method, then you can use it. Derivative is required at x equal to 3. Here we don't care if 3 is in the beginning or in the end. So you can use divided difference or Lagrange interpolation. So here is the table for the divided difference. You know how we do that. 15 minus 21 will give you 15 plus 21. And in the bottom we divide by 1 minus 1 minus 1, this will become 2. So this is our first divided difference. Again 12 minus 15 and 2 minus 1 in the bottom, this will give you -3. And in the next step you will skip this 1 and this 3 and you will get the second column here. And moving on you will get the, skipping the values between these values, you will get the data values here. So the upper diagonals are the divided differences. This one, the first one, this one, and this one. So since 4-point data is given, so polynomial should be of degree 3. We know that if 4 points are given, so the degree of the polynomial is 1 less. So again, using the same formula as previously we used in previous classes, again, it is a use of product rule and the linear expressions. So differentiation should be easy here. The derivative of this is 1, 1, 1. Here we are going to use the product rule again. Product rule going to be used twice. So the first derivative at x equal to 3 is, if we differentiate, then you will get this expression, x into x plus 1, x minus 1, x minus 2. So I would suggest that you solve this on the paper instead of listening or reading the notes. It is better to practice these. The second derivative at x equal to 3, again, this was a polynomial of degree 2. Here, 2 degree polynomials. Differentiating, you will get us 1 degree polynomial. So this is the 1 degree polynomial. Putting value of x equal to 3. So you will get the answer. So substituting values, in the end you will get -10. First derivative at x equal to 3. Putting x equal to 3 in the second derivative, you will get 0 value here. Second derivative at x equal to 3. So that was our lecture today. So please practice these questions and then we can, in on-campus class, we will discuss it again.